so you want to wobble. In this video, we're going to build a LFO Rate Quantizer into your Werkstatt. For this project, we'll need a breadboard, a 10K resistor, a 2.2 microfarad capacitor, a Phillips head screwdriver, some jumper cables, and an Arduino microcontroller. You'll also need a way to upload the code to the microcontroller. I'm using this laptop. First, take a Phillips head screwdriver and remove the top 4 screws on the Werkstatt. Inside the PCB, there will be screws holding the board to the chassis. These are the screws that you'll need to get ground off of. Simply strip one end of a jumper cable, wrap it around the ground screw, and tighten. Now that we have our ground jumper cable, we can put the top panel back on. Take your ground jumper and patch it into the breadboard. Using your 2.2 microfarad capacitor, patch the negative side, which is the smaller lead on the capacitor itself, into ground. Using your 10K resistor, patch this into your breadboard with one end touching the positive lead on the capacitor. From here, take a jumper cable and connect it to the other lead of your resistor. Now, we need to connect this jumper cable into our Arduino. For the LFO Rate Quantizer, we're using digital output 6. In the included code, we're reading the keyboard control voltage on the analog input 0. So patch a jumper from KBCV out into A0 on the Arduino. Now we need to make sure that our Werkstatt and our Arduino are grounded together. Take another jumper and run it from the ground connection on the negative lead of the capacitor into the ground connection on the Arduino board itself. Finally, we're ready to run signal into our LFO. The LFO in on the Werkstatt takes a voltage and changes the LFO rate. Take a jumper cable and run it from the node where the resistor and capacitor meet on the breadboard. This signal runs into your LFO in. Now we're ready to upload our code. The LFO Rate Quantizer code has 2 main variable arrays. The first one being the CV note array. These range in value from C1, D flat, so on and so forth, up to C2. The second array contains all of your quantized note value information. These are laid out as quarter note, quarter triplet, eighth, eighth triplet, so on and so forth, up to 16th note. For this modification, I've assigned a quarter note to C1, a 16th note to C2, and a quarter note triplet to E flat, or D sharp. To get this effect with the LFO Rate Quantizer, I'm simply setting the LFO to triangle wave, putting the VCF mod to LFO, and the amount to 100%. But since we're affecting the LFO, this is not limited to a dubstep sound. We can switch and actually modify the pulse width modulation via the LFO on a pulse wave. So we're not limited to just these quantization rates. We can change them in the code depending on what note we're pressing. Once we change anything in the CV note array, that quantized value will be read from the same index at the rate value array. For example, in this code, you can see that E is an 8th note triplet, but the F above it is a 16th note. By using our Arduino and manipulating the code, we're able to extend the functionality of our LFO. All parts list, Arduino code, and fritzing models are available online at werkstattworkshop.com.